All right, hi Jake. I'm recording for the first time this year, so hopefully this is gonna work. And Chase has to sharpen his pencil. There are 3 sections. Come on, kid.
Are we recording?
Yeah, we are recording.
Oh,
there are
hi,
3
Jake.
sections to this note sheet. 040506. So you have 3 homework assignments all together. Put them on the same page. It looks like a lot of problems, and it probably is a lot of problems, like over 20, which I usually don't give you, but they are very, very short. They are like PEMDAS. They are like solving things that are easy, okay? So write that down quick if you are still writing. You can look up there on the board as well. It's up there on both Tuesday and Wednesday. And there's that, okay? I'm going to zoom out. Algebraic expressions, PEMDAS. Please excuse my dear Aunt Sally. That's how you remember it, okay? P stands for what?
Parentheses.
Parentheses. I'm going to just do parentheses up there. E stands for?
Exponents.
Exponents. EXP. Multiplication, division, those are both together. So times and divide. And then add, subtract are all on the same level. So plus and minus. So we really have 4 levels of PEMDAS because multiply, divide is on the same level. Add, subtract is on the same level. Now what happens if you have multiple multiplication in there?
You go left to right.
You go left to right. So I'm going to put over here left to right. Everything is left to right, but you do them in that order. Have you guys seen on like Facebook or social media or TikTok or whatever, where they'll give you like weird things and they'll say, solve this, and people come up with the wrong answer? Okay, so it was like, I don't even remember what it was, like 2 times 100, no, let's do 2, I think it was like 2 plus 100 times 0 minus 3 or something like that. I don't know. That wasn't the right answer.
-3.
Okay.
Or it would be no. -1.
Yeah, -1. Negative. Who knows?
So a lot of people probably got like -3 because they did 2 plus 100, which is 102, right? They did it this way. 102 times 0 is 0. Minus 3 is minus 3. But what do you do first in that case? Multiply. You multiply correct first. So this becomes 0. So you really have 2 plus 0 minus 3, which is -1. That's the correct answer. But have you seen those on social media? They'll do those, okay? So remember your PEMDAS, your order of operations, okay? Now, one thing I want to talk about is the parenthesis thing, because a lot of people get parentheses really confused-ish, okay? They see something like this and they'll say 2, like this, minus 4 plus 7, I don't know, whatever, okay? Even though that has parentheses, those parentheses are not doing anything, right? Does that make sense?
Yes.
So when it says parentheses, you are simplifying the stuff that is inside of the parentheses. So 2 is inside of parentheses. Can he be simplified anymore? No. So if it had something like this with parentheses, like 3 minus 7, you could then simplify that. But if it's a number inside of parentheses and you can't actually do anything to simplify it, then your step is done. You skip over the P, right? Okay, so let's go down here. A, B, C, you're just plugging stuff in, and they want to make sure that you know your order of operations, okay? When you're plugging stuff in, you always put it in parentheses, okay? Because if you have a negative number, it will make a difference, all right? So this is what we're plugging in, x minus 5 plus y, and x is 15, so we're going to plug 15 straight into there. Minus 5 plus y is -7, okay? All right, so starting with parentheses. Can we do anything more with the parentheses? No. Even though there's parentheses there, like the parentheses are done for us. The only other thing that we could do is take them out of parentheses, like this is 15 minus 5, but what does plus minus 7 do?
-7.
Just -7, just -7. Okay, now I'm at the addition and subtraction step, so 15 minus 5 minus 7. 15 minus 5 is 10, minus 7, 3. Is that what you got? Okay, perfect. All right, let's go down to the next one. 2k plus n over p minus 3. I'm going to start my division bar here. 2k is -2 plus n is -4 all over p minus 3, and p is 5. So I have 5 minus 3. Okay? All right, so let's simplify the top. What does your top look like? Just do the next step. -4 minus 4, because I'm going to combine the plus and minus together. 5 minus 3 on the bottom is 2. Okay, so let's do one more simplification step. -8 over 2. And the final answer is -4. Are we happy with that? Good? Okay. Now, I realize that you could probably skip some of those steps if you want to, and that's fine. Write down some of the work at least. At least write down what it looks like after you plug it in. But you can simplify some of those steps in your head, okay? So now we've got this stuff going on here. What are these little bar things?
Absolute value.
Absolute value, and that turns everything positive. Okay, now, absolute values are kind of like parentheses. So pretend that there's like a imaginary parenthesis inside of there, all right? Because we're going to simplify that stuff first, all right? 3 absolute value. A is -2 minus B is -4. Absolute value plus 2. Absolute value C is 3 minus 5. Holy cow, there's lots of stuff going on here. This might be a little bit more complicated. Okay? All right, what are you going to do first?
-2, +4.
Yep, so minus a -4 is +4, right? -2 plus 4, okay? I cannot tell you how many times I have seen people multiply this by 3 and multiply that by 3. You see why? They're distributing because they're doing multiplication. Okay? Because multiplication comes before addition, right? Multiplication comes before addition. But these are inside of like little parentheses, basically. The absolute values are kind of like parentheses. Okay? So we cannot distribute the 3 first. We've got to combine these guys. Okay? So we have 3 absolute value of -2 plus 4 is 2. Yeah? Plus 2, and let's do this guy right here. What's 3 minus 5? -2. Okay, now let's do another simplification. Let's get rid of our absolute value bars. So absolute value of 2 is just +2, right? So 3, and then what is the 3 doing to this 2 right here? Multiplying. They're right next to each other, so I'm just going to write it as 3 times 2. I'm just going to get rid of the absolute values. Plus 2 times 2, right? Because that absolute value changes him from -2 to +2. Okay? So I've got 6 plus 4 equals 10, right? Okay, order of operations. Good? All right, one more thing I want you to put off to the side over here, that there is a difference between -2 squared and -2 squared. Okay? When you are dealing with parentheses, there is a difference between the two. Okay? -2 squared, -2 squared. There is a difference between those two. Did you know that there was a difference between those two? No? Okay? So in this top one right here, the only thing that is being squared is the 2. So this is kind of like negative is hanging off the side, and then we're squaring the 2. So we're taking 2 times itself and then adding the negative later. Right? Does that make sense? Okay? So this guy is -4. Versus this one, we're squaring the negative and the 2. So we're taking -2 times -2 like that. So that one is +4. So when you are plugging numbers in, it does make a huge difference whether you have parentheses or no parentheses. Okay? Do you see why that top one is negative? You're only squaring the 2 and then adding the negative later. Okay? So order of operations, that's how it goes. Note, always use parentheses when substituting. We talked about that. All right, let's go down. Example 2. There are 5 examples underneath of here, but they take really not very long. Solve each equations. These are linear equations. What does linear mean again? A line, if you would graph them. But what else? How do you know that they're linear?
Because there's an equal sign.
There could be an equal sign and be like an x squared, and that's not linear.
Because there's no
Because
x
there's
squared.
no x squared.
Right? It's one variable to the first power. So my variable in this first example is m, and it's just m. It's not m squared, it's not m cubed, it's not m to the 4th power, it's just m. So these are all going to be linear. These are all just going to be like solve and get the m by itself. So how do I get this m by itself over here?
Guess test.
Guess and test. -12 minus 12. M is equal to?
Negative 17.
-17. There you go. There he is. M is equal to negative 17. Okay, over here, we want to get this t by itself. T is dividing 8. So we want to multiply by 8, but also let's multiply by negative 8 so we get rid of both of those at the same time. We'll multiply by negative 8, that makes it go away. Times negative 8 times negative 8. T is equal to 56. Positive or negative 56? Positive, because there's two negatives, right? Is this making sense? Are we okay here?
Yep.
Okay. C, we have 3/5 x. I want to get that x by itself.
Divide by 3/5.
You're dividing by 3/5, but also instead of doing that, we could
Multiply by 5/3.
multiply by 5/3, right?
Really easy.
Times 5 over 3.
Gilly Suze.
And that makes this go away. Times 5 over 3. The 5's cancel, the 3's cancel. So I'm going to do the same thing over here. Times 5 over 3. Okay, now I have a fraction times a whole number.
Make the whole number a fraction.
Make the whole number a fraction. Put it over 1. Okay? Now, how do you multiply those together?
You
8 to the 3. 8 to the 5.
5.
Which is
40.
40
And
over 3. Now, if you forget to put that 8 over 1 and you just do this, 8 times 5/3, I cannot tell you how many times I've seen this. 40 over 24, because what did they do?
Multiply 8 by both parts.
That would be taking it times 8 over 8, which is really like taking it times 1, which is not what you're doing, right? You're taking it times 8 over 1. So don't do that. You're only multiplying it by the top. Okay, one thing's wrong with our answer.
Negative.
Negative. We could simplify, but I don't think either one of those will reduce. You could change it to a mixed number. How many times will 3 go into 40? 13 and a third.
Yep.
13 times 3 is 39. Okay, whatever. You can leave it as negative 40 over 3. I'm fine with that. Okay, if you don't want to have to simplify. But reduce, if it can be reduced, please reduce. Okay, good. Next two. D, there's 4 pieces there, and here's my equal sign. Woo! Do you remember how to do this?
Subtract by negative.
We want to combine the y's or the variables together, and we want to combine the numbers together, right?
Subtract by 6 and then.
You want to subtract the 6y, so we're gonna bump him over here. Subtract 6y. Okay. So 12y minus 6y is 6y plus 8 is still hanging on there equals
So you subtract
negative 5. What?
Subtract by 8.
Now you move the 8 over because I've said that the variable's going to go on the left side, so I want the numbers to go on the right side. So I'm going to subtract the 8 over to this side. 6y equals negative 13, you said? And then divide by 6. We'll just leave it as negative 13 over 6 because it doesn't come out nicely. Or negative 2 and 1/6.
I'm so smart.
Something like that. My bubble isn't working very well. There we go. Okay, happy with that? Okay, get the variables to one side, the numbers to the other side. Good? All right, well, what about E?
Distribute the 3.
Distribute the 3. 3 times x, 3 times negative 5.
3x minus 15.
Yep. I have a lot of people that will distribute the 3 to the x and not to the 5. Make sure you do it to the 5 also. Now what?
Add 15.
Add the 15. Is this too easy?
X equals 28.
3x equals 28. X equals 28 over 3. Can you divide that in your head? How many times does 3 go into 28?
9.
9 with how many remainder?
1.
1/3.
Can we just leave it not?
You can leave it as 28 over 3. Okay? But in geometry, we do a lot of like trying to divide stuff in our head because that will help us get ready for the ACT when we're trying to save time. Okay? So get into the habit of kind of like figuring out what some of that stuff is in your head. Okay? Last section. Blah, 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 blah. Okay. We have to solve these, and we have to solve each inequality and write your answer in set builder notation. Don't let me forget to do that, and I'll show you what set builder notation is, okay? Let's go back up to here, and let's talk about A for just a second. We got negative 17 as an answer for A, and what that means is that this statement right here, m plus 12 equals negative 5, is only true if m is negative 17. Does that make sense?
Yes.
That statement is only true if m is equal to negative 17, okay? Down here, though, we have an inequality, which means not equal, And if it's not equal, it's either less than, less than or equal to, or greater than or equal to, like these symbols right here. Okay? You only switch the sign if you're multiplying or divided by a negative. We'll get to that. Okay? Now, on here, it's the same algebra, the same math as what's up here, except you're going to get a range of answers. Okay? So let's go ahead and solve this one. Get x by itself. What do we need to move?
X is greater than 20.
We add the 17 over, add 17 over. X is greater than 29. Okay? Now, that means that any number that is larger than 29 will make this statement true. It's not just one answer like it was up here. It's not just negative 17. It can be any number greater than 29 that will work in that answer. Okay? Now, can it be 29 exactly?
No.
No, because it's not equal to 29. So the number 30, if I plug 30 in here, that will work in this statement. If I plug in 57, that will work in this statement, okay? I'm going to put off to the side over here what Jayton just said. Only switch sign if multiply or divide by a negative number. Any negative number, you flip the sign. Okay, if it's less than, it switches to greater than. If it's less than or equal to, it switches to greater than or equal to. Okay, if it has an equal to, you leave the equal to. You just flip the sign. If it doesn't have an equal to, you don't have an equal to, and you just flip the sign. Okay, we do that on the next one. Part B. There's a D here. What are you going to do to get the D by itself? Okay, think about what it's doing to the 13. This says like D divided by 13. So Kyle says the opposite of division is multiplication. We got to multiply. But since there's a negative there, let's kill two birds with one stone. Let's multiply by negative 13 to get both of those things to cancel out, right?
Well, it's not nice to kill birds.
Sorry. Negative 13, get it to go away. D is left on that side except, now what's the symbol?
50. Oh, the greater than.
Greater than or equal to. Do you guys know the difference between, if I say less than, can you draw me a less than sign?
Yeah,
You
the
know which one?
crocodiles.
You know which one is less than?
Crocodile.
You read it left to right. So less than, and actually less than makes kind of an L sideways, right? This is like a sideways L.
No, it's a crocodile.
Okay, whatever. Less than, the less sign is on the left and you read it left to right, okay? D is greater than is what it's switching to what? Negative 4 or negative 13.
52.
Is it 52?
Yeah.
I think you're right. Positive or negative?
You should know this.
Positive or negative?
Positive.
Positive, because there's two negatives. So this is saying that any number greater than or equal to 52 will work in that statement and make it true. Yes?
Yes.
Okay?
You're,
C.
it's Tuesday, January 9th again. It's frozen back to what it was.
Because I'm recording, so I had to do it the same method as I did last year. I'm not screen mirroring.
9:41. Oh my god, the
Yep.
memories.
Ah.
Tuesday, January 9th.
It when I'm recording, it
At 9:41.
does it that way. I don't know.
In the celestial world, it is
So
now
anyway.
Tuesday, January 9th.
All right, so here's your equal sign, and we have 4 pieces, and we have to move all of the variables to one side and all the numbers to the other side. What would you like to move first?
The -1.
Okay, let's add the 1. Plus 1, get him to go away. So now we have
Divide by
4z
4
plus, hold on, we can't divide by 4 yet.
divided
4z plus 8 is greater than or equal to 8z. I wouldn't divide by, I mean, those are all divisible by 4, but I wouldn't divide by 4.
I mean, I think we should subtract 4z.
Okay, so I have a z, I have a number, and I have a z, so I have to get the z's together. So you said subtract 4z over to the other side?
Yep.
Okay, 8 is greater than or equal to
4z.
4z, and now
Divide by 4.
divide by 4. Now divide by 4. Z is less than or equal to 2, or 2 is greater than or equal to z. I don't like to have it written that way, so I flip it around. I put the z here and the 2 here, but when I flip it around, I have to make sure that the sign is flipped also. Okay? All right, now, last thing. They wanted it in set builder notation. Put the answer in set builder notation.
I think they're
So-
getting a little too picky.
I know. It's already kind of in set builder notation. You just have to add some things, okay? So, A, we said X was true only if it was greater than 29, okay? So, for our set builder notation, You write it with the little curly Q brackets. Let me try those again. Curly Q brackets, if you want to make your squiggles like mine, that's fine. This is what set builder notation looks like. You have to first define your variable, which we called
X.
X is my variable. And then we say only X's where X is greater than 29 work. So we say X such that, this means such that, it's like a straight up and down line. Straight up and down line. X such that X has to be greater than 29. That's how you put it in set builder notation.
stupid.
Yeah, there's no
That's set,
point.
that's set builder notation. It's kind of silly, but that's what it is technically. Okay?
Kinda silly.
So you define your variable, and then you kind of put a border here, and then you write the rule after that. Okay, so putting the other ones in set builder notation, we're defining the variable on part B, and the variable is D, such that we're talking about only D's that are greater than or equal to 52. That will work in that equation. Okay.
It's dumb.
C,
Just a waste of time.
the variable is Z, such that Z's have to be less than or equal to 2 in order to work in that equation, and that is set builder notation. Okay? Good?
Yep.
Happy
Why
with that?
do you do that?
I know, that's just
It
the
doesn't-
technicalities of it.
literally
okay?
wastes time.
I know.
and that's it.
I know.
That's just
So,
the reason we give mine to
3
boys.
sections together, right? 3 sections together. That's your homework assignment. You can put it all on one page.
Yeah.
You have lots of time to finish, to work, and probably finish this, even though there's a lot of problems. They are really, really short,
Have
yeah?
you ever seen
Bye,
a
Jake.
class
Bye, Jake.
Have fun, Jake.
Don't leave me.
See you later.